class. Welcome to lesson 1.8, transforming graphs using mapping. As we discovered last class and the class before that A does a vertical stretch and compression in the from the up or low, like from the top or the bottom. So stretching from the top or the bottom, you can either stretch it thin like an elastic, or you can actually push it and squish it. Likewise, we also learned last class was the K factor. The K is a push or pull in the horizontal direction, so it either can be push or pull. Just remember that factor when you're dealing with K, that it's really the 1 over the K that gives you that stretch or compression in the horizontal direction. So if we take a look at today's lesson class, we note that if we take a look at our formula that we remember from last days dealing with the transformation, we have it now complete with all the letters in it. So it's y equals a applied to any function that we take the k, and then it's x minus d, all of that, and then add c. Again, that applies to any parent function, ladies and gentlemen. So what we can do, as long as we know what parent function it is and what the letters for a, k, d, and c are, then we can simply take a look at the transformations. Now, what is difficult is the graphing, ladies and gentlemen. Why is that? Because we have the factor of A pushing or pulling in a vertical sense, as well as the K factor, which is pushing and pulling in a horizontal sense. And sometimes it's difficult to graph these transformations. That's why we're going to break it down and use what's called mapping. Okay, so if we take a look at this formula that we have right here, ladies and gentlemen, we notice that if you take a look at A and the K, they deal with the stretching, compressing, and reflecting. That's going to be stage 1. So if you look down here in this box, right here, stage 1. So we're going to deal with the parent function first. Then we're going to take a look at the stretch and compressing and reflecting. And then, lastly, we're going to deal with the translations, i.e. the up-down movement or the left-right movement, which corresponds to the last section of our mapping sequence. Also, make sure you note here, folks, that we're dealing with the horizontal movement. Okay, that has the effect on the X, whereas when you deal with the vertical movement, which the letters are A and C, that deals with Y. That's why you'll notice that when you look down here, ladies and gentlemen, at the mapping formula, that we notice that the K and the D are all attached to the X, and the A and the C are attached to the Y. And when I mean that, I'm talking about the ordered pair. So this starts with original ordered pair from your parent function. Then we apply the K and the A, which is your stretch, compress, or reflect. And then lastly, in the third section, we do what's called the translations, which is your up-down movement or left-right movement. Okay? So taking a look at this diagram here, ladies and gentlemen, what we're going to do is use this example here, example 1. So if we're given g at x right here equals 2 times any function, the negative 1/3, that's our k, times x plus 1, closing bracket, negative 4. So from that, we should be able to deduce that A equals 2, K equals negative 1/3, D equals negative 1, and C equals negative 4. All we need to do now is take a parent function. So for example, A, we're going to use the reciprocal function here, okay? And we are going to then map these 3 different sections. Each category, folks, or each color, if you notice here, will be a different graph that we're going to use. So I would recommend when you're doing this, folks, that you use 3 different colors to help us out. One thing to make note here, folks, when we know our parent function, which is y equals 1, or f at x equals 1 over x, we notice that there's 2 things that are really important, and these are our asymptotes. So we're going to include them in our graph, okay, because it's going to help us decide how to draw our graph. Okay, so first of all, when you remember, when we take a look at our parent function 1 over x, or reciprocal function, we notice that there are 2 asymptotes. That's why in our table of values here, we do not select the values of 0. So we're going to go 2, 1, we're going to go close to 1, which is a half, and then close to 0, which is a half, and close to 0, which is negative a half, -1, -2. And all you do, ladies and gentlemen, is sub it into your parent function here, right here, to get your answer. So when you sub in x equals 2, y equals 1 over 2. That creates your ordered pair here. And you fill that in for all of your table in the first column. Okay? Next step, ladies and gentlemen, is to incorporate, let's start over here with x divided by k. So x, ladies and gentlemen, stays there, but when you divide k, which is a -1/3, remember you've got to flip that fraction to get the what we call the reciprocal. You flip it over, and that's how you can come up with -3x. In this case, folks, there's no absolute value for k, so that is deleted here because we need the negative, which tells us that it reflects the y-axis. Okay? Then we do the y component, which is a times y. So a in this case is 2, so it's going to be 2 times y. So from your first ordered pair here, guys, you're going to take the first value, which is 2, and what's happened to it, you're then going to times it by -3. So 2 becomes -6. And you do it all the way down there. 1 becomes -3. A half becomes -3 or 2. All we're doing is taking the x-coordinate from our first column and timesing it by -3 to get our second column here. To complete the second part of the ordered pair, you take a look at what you had in the y column here, and then you're going to times everything by 2. So 1/2 times 2 is 1. 1 times 2 is 2. 2 times 2 is 4. So again, we're building on these ordered pairs. So ladies and gentlemen, the blue, or the second column, is the change that's happened, i.e. with the reflections, the compressing, and the stretching in both the A and the K. That's why it's difficult to graph that. That's why we use ordered pairs in a table to help us see that. Notice, ladies and gentlemen, when we do stretches and compressions, that the asymptotes do not change. They stay the same. Then when we do translations, that's your D and your C, ladies and gentlemen. So again, D is -1, so it goes in there, and C is -4. So basically, you're taking what you've done in the blue column and you're just subtracting 1. So -6 subtract 1 is -7. -3 subtract 1 is -4, and so on and so on. Likewise with the y part. You start with 1, and then it says to subtract 4. So 1 subtract 4 is -3. 2 subtract 4 is -2, and so on and so on. Once you've completed the chart, you will notice that, hey, if we do a translation, that affects the asymptotes. So here you will notice that if C is -4, that means your y-intercept or y-asymptote is going to go down to -4. Likewise, the vertical asymptote, x equals 0, it's going to shift to the left one because it says -1, so that's going to also affect the asymptote. So basically what we do now is we take each graph and we're going to graph them on the same grid using the same color coordinated colors, okay? So if I focus on, ladies and gentlemen, the first graph, which is your black graph, that's your parent function. Notice the key point here is 1, 1 and -1, -1. So you graph those to the asymptotes. Then when we do the blue graph, which is your second one, you're going to see that the shape has changed a little bit. You will notice that no longer is your point at 1, 1, but it's have to be reflected. It's reflected the y-axis, and it's been horizontally stretched by a factor of 3. So you plot your points there, and from your blue graph to your red graph, it's the same graph except it's just shifted either up or down or left or right. So that's a direct translation. Notice when you draw the red graph, your asymptotes have changed. Okay? So now when this question C says to sketch all 3 graphs showing each stage, this is time you're going to have to practice doing this, ladies and gentlemen. This is a major question on your unit test, and you need to make sure you can do 2 of these mapping questions, okay? So please make sure that you are ready to do that. Okay, so it says to sketch all all three graphs and state the domain and range of the final function. The final function is our red function. Okay, so let's focus on that to take a look at how we're going to do our restrictions. If it's helpful, let's take a look at the black one just to get us to our parent function again. And it's a reciprocal, so if you have a reciprocal function, it's the parent function. X belongs to a set of real numbers such that x cannot equal 0. That's because it's the asymptote, the the vertical asymptote, right guys? When you're taking a look at the range, okay, range is such that y or f at x belongs to a set of real numbers such that y or f at x cannot equal 0. That again is your horizontal asymptote. What's changed, ladies and gentlemen, is when we take a look at the transformations embedded in the final, or the red graph, the final graph, guys, we notice that x belongs to a set of real numbers, but our asymptote has moved to the left one, so x cannot equal -1. Likewise, when we do the range, the g at x, or your function, belongs to a set of real numbers such that the g at x cannot be equal to 4. Again, that's your asymptote that's moved down here. All right, let's take a look at the next page here. All right, example 2. If you're given f at x equals the absolute value of x, state the transformations applied to obtain the graph of this following function. Notice this, ladies and gentlemen, right here. Again, the function exists on the right side, so you can't graph it as it is. So the first thing you need to do is sub it into your parent function, which is your absolute function. And in this case, folks, you've got to be very careful, and please remember to do this. On unit tests, people forget to do this. You're always going to have to check to see if you can factor out k. So looking here, ladies and gentlemen, you notice that there's a -3 that can be taken out of both of these terms. So let's do that. So k is -3, and what's left over is x minus 2. That affects your d value, folks. So please make sure you're aware of that for your unit test. Once we now have it in our parent function form, the f at x is gone out of the right side, so we could actually graph it, and we can apply these transformations directly to the absolute value parent function. So in this case, a, which is way out front here, right here, guys, a is 1. So that means there's no stretch or compression vertically, and there's no reflection of the x-axis. K, on the other hand, is on the inside of the absolute value bracket, and it's also factored out. So k is -3. The negative means that it reflects the y-axis, and the 3 part tells you it's a horizontal compression by a factor of 1/3. And then we can take a look within our brackets there. We've got d equals 2. That's a horizontal translation, which means we're going 2 to the right. And notice there's no constant value out by itself, which means c equals 0. That means it stays on the x-axis. That allows you enough information to then graph this if you're able to. Ladies and gentlemen, your homework for today is a handout on graphing transformations of parent functions. Try as many as you can. At least try to do 2, folks. I will post the answers and go over them with you during next class. Again, please take note, folks, that this is an important concept. It's your major application question on your unit test because you're summarizing everything that we've gone through, including the a and the k and all your transformations and all your parent functions. So it's a good summary. So please make sure that you've got this spot on, and please come see me if you need some help.